please give a warm welcome to today's speaker, Derek Finn, PE, Director of Operations of the Structural Division at Drake Williams Steel.
Thank you, Jeff. So today, myself and Justin Jensen, we're going to talk to you guys about how at Drake Williams Steel, we schedule our shop resources to create productive flow. And throughout the presentation, we're going to use different lean terminology. That's kind of what we use to guide a lot of our resources. But we're going to talk about it from the Drake Williams Steel approach, what philosophy and tools we use to do that. Before I get into it, I do want to thank everybody for coming this morning. I know 8 o'clock on a Friday morning, a long week of this conference, late nights. So I appreciate everyone in attendance, both remotely and here in person. So we're going to kind of cover, touch base on two different aspects of the resources that we schedule. We're going to look at it from how do we manage our overall backlog, kind of a global view of our overall backlog. And then we're going to kind of dig into the day-to-day operations, the day-to-day resources that we have to schedule and manage. From the backlog standpoint, we're going to look at the tool that we've created and used to manage the overall schedule backlog. We're going to talk about how we manage both our current backlog and then our potential or projected backlogs. And then we're going to talk about how we use those tools to manage change, too, throughout the process. And we all know, as a fabricator, that change is a regular occurrence and happens pretty much daily in our lives. Justin's going to start to talk about how do we manage our daily resources, what tools we use to manage those, what level of detail we go to in those tools and why it's applicable to what we're doing. And then, like I said, throughout the process, you might hear some lean terminology that we use, and that's kind of, we use lean philosophy and lean principles to really guide a lot of the processes and decisions that we make to help define our productive flow. Before we kind of dive into it, I just kind of want to give you guys a little brief history on what Drake Williams Steel is. It might give a little bit better understanding of why we do what we do and how we do it because of the size of our operation. So Drake Williams Steel, structural steel fabricator, been around for 140 years. We have 4 different divisions. Me and Justin work out of our structural division in Omaha, Nebraska. It's about a 270,000 square foot fabrication facility where we focus on structural and miscellaneous steel. We have a Mountain Steel division, which is another structural fabrication facility here in Aurora, Colorado. It's about a 50,000 square foot facility, kind of just a smaller version of what we have in Omaha. We have a rebar fabrication facility in Omaha, Nebraska. And then we have a coatings division where we focus, their primary focus is powder coating and liquid paint applications, and they're in Council Bluffs, Iowa. Like I said, me and Justin work for the structural division in Omaha, so we focus on structural and miscellaneous steel fabrication scheduling. Between our structural fabrication plants, we're producing about 40,000 tons annually. That translates to about 400,000 man hours throughout our facilities. And in 2014, we became an employee-owned company. We've been family-owned for 33 years, whatever it was. The last 2 Williams brothers decided to get out, and so they sold the company back to the company, or to the employees. And it's been exciting because now as an employee-owned company, it gives us that extra drive to really work to improve our processes. And because at the end of the day, every improvement we make, every process we enhance, we're going to reap the benefits of that because everything's staying in the company now. So that's kind of given us that extra drive to really, analyze and evaluate what we're doing as a company. So why is effective scheduling critical to our success as a fabricator? And I can really kind of give 3 main reasons as to why it's critical that we focus on improving and enhancing our scheduling practices. First off, facility and resource utilization. As a fabricator, we have a lot of money invested in our facilities and all the assets and resources of those facilities, equipment. As an operations director, I like to look at our facility and say that we're utilizing every square foot of that for value-added functions. Value-added for both our external customers and value-added for our internal customers. So it's critical that we utilize every square foot of our facility. In turn, too, with that, all the resources within the facility, the equipment that we have. We purchase equipment based off an ROI, and that ROI is going to be based off of that machine running. If our machines aren't running, if the runtime is not where it needs to be, we're not capitalizing and realizing the benefit that we invested in that equipment. So once again, we want to utilize every square foot of our facility for value-added functions. We also want to make sure that our machines are running, that we have that runtime, and those are things that we monitor on a regular basis. Secondly, as a fabricator, we sell material and man hours. I mean, that's basically what we're doing. So it's critical that we keep our production workforce busy and efficient, and also a constant level of production. It's really those ebbs and flows of production that really introduces different types of waste in our facility, standing around waiting, and that's where we're not capitalizing and benefiting the most we can from our success. So if we have a constant flow of material and man hours throughout our facility, we're going to realize the benefit of that, and we're going to be successful as a company. So, and last but not least, surely, is our customer commitments. As a fabricator, our word is everything, and those commitments we make to our customers is critical. It seems like that most customers, it's kind of, what have you done for me lately? And so you might have 5 projects where you deliver everything on time, but that last project, maybe you were late on a sequence delivery. And that's probably what they're going to remember on that next opportunity you have with them. So it's critical that we have confidence in the level of commitment that we're making to our customers. And the best way to have confidence is to really understand your schedule and effectively schedule your resources. So I'm going to touch base on the backlog, how we manage our current backlog, and the tool that we use. This is our backlog management tool that we use. It's a shop schedule. It's what we refer to it as. It's basically an Excel file on steroids. It was created over 20 years ago. It's been updated and modified over the years, and we continually update it as needed. But the kind of general layout of this is going to be an overall view. This is our dashboard for our division backlog. And so we have multiple divisions, so each division will have a shop schedule assigned to them, and they'll create it themselves, manage it themselves. And the general layout of this is on the left side of this document, we list all of our main projects that we're running through our facility at that time, and we assign a contract job number to it. Along each of those lines, each job number is going to have the estimated hours that are assigned to that project. They're going to have the amount of hours that we schedule on the production side. They'll list tonnage, just some kind of key metrics of the project. And then along the columns, you have each individual week of a year. We map out our backlog for a certain time period. And then what that does is basically what you're seeing here is every value that's in a week for a specific project, that's the amount of hours that we have scheduled for that project that specific week. And so we're basically taking and having that information there in the middle, but the information on top is providing us, that's where we have our current manpower levels, and we take and we develop and we identify what our overall production capacity is based off of our manpower levels. So we have X number of employees that week in our shop. We are going to produce, we have 10% indirect hours, so we're going to have 90% of those hours are going to be direct labor function hours, and so that's going to be the available capacity. And what we're basically doing is we're comparing the amount of hours we're scheduling based off of our projects that we have, the estimated hours, and the customer commitments we've made. We compare that to our available capacity. So right there we have a good idea of, okay, we're scheduling all these hours, and this is the amount of time that we have available in our shop to support that. And basically what happens is, this is kind of the dashboard, the overview, where all of our individual information is going to feed to. But to get to more detail, each of these projects will end up having an individual project tab schedule within this document. And that's what's feeding that main dashboard. So you had project 1, 2, 3 was showing that I'm going to work 200 hours this week on that specific project. But what we do, where that information comes from, is we're defining it down to the project level specifically here. So once our project managers work, we kick off the project, the schedule is defined, the sequencing for that project is defined, we'll then take and create the specific project tab. And in that project tab, we have each specific sequence. We have the estimated hours that we got from the project manager for that sequence, the delivery dates, and then we go through and we itemize each sequence and schedule it in our shop. And this right here is a representation of. So we have each specific project sequence identified. We know when we're going to start it. We know when we have to have it ready to deliver, and it kind of defines the duration. But what this does is this is communicated to all of our employees, and it gives them a good overview. Project managers can look at this tool and say, hey, this is when they're starting my project. This is when they expect to start this sequence. Our production employees know, hey, this is when I need to start this project based off of this schedule. And kind of what we do in Justin's, the kind of main brains behind this, is we take and combine all of our project schedule information, all the estimated hours that we have. We bring it all together, and then we're trying to support all of our customer demands, but while we're not trying not to overload our production workforce based off of the available capacities. So what that does is that then produces these backlog summary charts. And we have a different backlog summary chart for each division, so division A, B, and C. And what the blue bars represent the amount of scheduled hours for that specific week for that division in production. And so from there, you also see the red, green, and red lines up top. The bottom red line is located based off of our current manpower, them working 40 hours a week. The green line is 46 hours a week, and the top red line is 52 hours a week. And so what this does right here, this gives us a graphical representation saying, okay, Division A, that first week, you have so many hours scheduled in your shop that it's going to require you guys to work 52 hours a week. And this has kind of been a tried and true thing that we've developed and kind of fine-tuned over the years. But this is really, we can really trust this to be pretty much the Bible when it comes to how busy we are going to be. You know, we've developed and we've learned enough about it that this is a really good, accurate representation that it's pretty close that we're going to have to work a fair amount of overtime that week. We know that. Now, when we look at that, we'll look at Division A and say, hey, it's super busy. We're way overbooked. We don't want our guys working 52 hours a week every week. You know, that's not efficient. They get tired. They get burnt out. It's unsafe. And so this gives us an opportunity to say, okay, Division A, you're really busy here coming over the next 6 weeks. Division B, yep, you're pretty busy too. Division C, well, now you're not quite as busy. You have some lulls in your schedule. So this kind of sparks the discussion between divisions of saying, hey, I'm overbooked Division C, you have some time available. Let's start the discussions of saying, hey, does it make sense for us to give you guys some of our work? Can we transition some of our workload to your facility, you know, to allow us to level out all of our shop schedules? Because at the end of the day, as Drake Williams Steel, we have multiple divisions. You know, we want to keep every division as efficient and busy as possible. So we try to balance the workload overall. Now we have to start the discussion to say, hey, does it make financial sense to send the work to this division? You know, depending on where the job is, the type of work it is, can that facility, you know, handle that type of work? But at least this sparks the discussion. And the other thing this does, this is once again communicated to all of our employees. They see it whenever they want it. We distribute it weekly. It's also a good tool for our production managers to say, hey, production workers, you can see that we're going to be super busy for the next 10 weeks, you know. So plan on working overtime, you know. Or if you're Division C, you might say, hey, guys, you know, we're going to have a lull coming up in the next 6 weeks. So, you know, if you have the possibility of scheduling vacation, spending time with your family, that might be a good time to do it because you guys might be a little bit slower, you know. The other thing that we have to do when we look at this is we're not just going to blindly say, well, Division A, you're overbooked. We got to start subbing work. Now we're going to dig into the detail of that number, and we're going to say, okay, what is the mix of work that we have here? You know, where is that burden going to fall? Is the burden across the shop? Is every single department busy? Or is that burden only falling on fabrication because it's a really high man hours per ton type work? So but this once again is just kind of a nice tool to spark that discussion, and it gives us a good view of, hey, how busy are we? And we can take and project this out, you know, as far as our backlog goes. So that's kind of how we manage our current backlog and some of the tools that we see that we communicate across our company to inform employees about how busy we are and manage that. But we also have to think about, okay, what's our potential backlog going to be based off of sales efforts? You know, what kind of potential projects are out there? What are they going to sell? And so another aspect of this tool is we have another tab where we have a potential backlog. And what that does is our current backlog feeds into that, but it gives us the freedom to take and add in different types of projects that are projected that we think we're going to have a high potential to land. And we also take and we map out our projected manpower for that extended period too. So every year we do strategic planning. We go through and evaluate how much do we want our divisions to grow by? How much can the market support? You know, and we want our divisions to grow by 15% this year. So we incorporate that 15% manpower growth into our projected schedules. And then we have sales, they're going through and they're selling to that projected growth. You know, we don't need our sales guys to sell to today's manpower for 6 months from now because we want to grow by 10 people. You know, so if they're selling to today's manpower, we're already going to be undersold because we have more manpower. So we want to make sure we have a good tool and a good way to track, you know, what is our projected manpower going to be, our projected available production capacity. And then from there, sales, we'll work with sales, we'll communicate efforts, they can input opportunities in this, we'll evaluate it. We might, you know, plug in a project that's 6 months down the road. We'll see how it fits in our backlog. If we identify some possibility, you know, some issues there, we might say, okay, hey, we're going to be way overbooked. We're probably going to have to sub some of this project or some other project, but at least it identifies that at that point, and we're being proactive with it. You know, We're not waiting for the week before something's due to say, I got to sub this out now because I can't meet the delivery date. This gives us a really good overview and a long projection of how busy are we going to be, and what opportunities can we bring in to fill holes, or where are opportunities at that we need to bring in. The other thing we do is when we go through our projected, our potential backlog, we do evaluate what is the mix of work. Once again, this is a lump sum of hours based off of our available production capacity and the estimated hours that we sold. But what is the breakdown of those hours? Does that burden fall on a specific department, specific type of work? When we get into larger work that has maybe large trusses, it might take up a good portion of our shop, so we can't really produce as much as we want to. Our man hours per ton is really going up. And so we have to take that all into consideration as we evaluate work moving forward, because it's not going to do any good to say we can sell these hours, but all that burden on those new hours is going to fall on fabrication when they're already filled the burden. So you got to kind of have to balance the opportunities with really where all that burden's falling. And then we use all these tools to help manage backlog change. It's critical, like I said, to understand what our current backlog is, understand the mix of work. We regularly have meetings weekly with our project managers where we discuss projects. We require them to really give us weekly updates on project schedules. How is the project trending? Are they delayed because of concrete issues, weather issues, whatever? Because for us, we've really transitioned more into a just-in-time fabrication shop where we don't like to work too far ahead. Now, there's times we might have to because we have a glutton of hours that we have to produce, but we'll manage that. But ideally, we want to get the steel out there, a few days, or we want to have it produced and loaded, a couple days before it delivers. And so in order to do that, we really have to understand what our project schedules are like and how they're trending, because realistically, if in 2 weeks we know a sequence is going to delay a few days, we might change our priorities this week because we know that one's pushing out, and we can modify it and maybe move something else around that'll help us, produce better on another project. So we're trying to be more real time, but that's the benefit of having the regular interaction that we need to have with our PMs. And we hold them accountable. We push on them. We want information. We need information. We can't schedule your project accurately if we don't know what the project schedule really is, and so we really want that information from them. Like I said, we get regular site updates, and then we go through and we evaluate our productivity on a regular basis, especially when we have larger projects that a duration might be a 20-week project. We'll get through the first maybe 4 weeks of that project, and we'll say, okay, how are we doing our productivity side? How is our production versus the estimated hours going? And let's say we're trending 15%, we're 15% under the estimated hours. We'll dig into the detail. We'll understand why we're 15% under the detail or underneath the estimate. And if we feel like and we have confidence that that trend's going to continue, then we'll modify our scheduled hours and reduce those by 15%, because now we know that we have extra capacity that's going to come, and that's also going to allow us to respond to change better. If we look at our backlog, we don't make any modifications for how our productivity is trending, we might look like we're really busy and we don't have any holes. But if we modify and update it for the real-time productivity improvements or when we're running over, then we can really have a better view of, hey, we actually have a hole here, or we have more available time. And then Project X wants to change some scope, add some scope, move it into that frame. Well, now we know we have time to support that change. And so really having the real-time evaluation of productivity, the real-time evaluation of project schedules, that's what's going to be critical to really helping you manage change on all your projects. So that's kind of an overview of how we manage, what I'll call the global view of our backlog. It's really important as we start talking about digging into the what Justin's going to talk to, the daily resource management, the day-to-day operation management. It's really important to define the level of detail that you're going to go to. And there's two aspects of that. There's the estimating level of detail and the production tracking level of detail. So, we're in the process right now of evaluating a new estimating software because FabTrol's going away, so we're evaluating different options. And we're trying to determine what level of detail we want our estimate to be to. Do we want to have just a lump sum of hours? Hey, Project X is 500 shop hours, go ahead and start producing it. Or do we want to have a detailed breakdown of that estimate? I want to know there's 50 saw hours, there's 40 drill line hours, there's 30 welding hours, 10 fitting hours, do we want to have that level of detail? And is your estimating system capable of supporting that level of detail? So you have to kind of determine that, and that's both of what do you want and what can you support. And then you talk about production tracking. Okay, same thing. What level of detail do you want to track your production to? You know, do you want to look to say, I have a shop of 10 guys, we can produce 200 hours a week, and that's what we're doing? You know, is that what we want to say? Or do we want to say, okay, I have a saw, I have a drill line, I have 10 welders, I have 10 fitters, I have 2 painters. You know, do you want to look to that level where we schedule the actual task or function? You know, those are decisions you have to make. But then the most critical aspect is whatever decisions you make, the decisions we make will be different than some of you guys, and that's fine. There's nothing wrong with that. But the critical thing is aligning those two decisions, aligning your estimate level of detail with your production tracking level of detail. Because it does me no good if my estimating system is producing a lump sum of hours of 400 hours for the whole project, and I'm tracking stuff to the saw level, and I want to know how many saw hours I really have, but I can't get it because I only have a lump sum of hours here, you know. So you really have to balance the two, and the most critical aspect is making sure that they align the best we can. And if you can get them to align, it's going to allow you to better manage the productivity side of your shop. You'll really be able to evaluate the productivity on that specific function level, whether it's by department, whether it's by task, whether it's by your shop as a whole. So level of detail from the shop schedule, the backlog summary that I showed you, you know, this is the level of detail we go to for that, and this is sufficient for what this tool is used for. You know, like I said, we break it down into the project specific tab, and we go through and we define the sequence level based off of delivery dates and estimated hours, and we define it that way. And that's a sufficient level of detail for what that schedule is supposed, that for the purpose of that tool. And so Justin's now going to talk about kind of the level of detail and what we do to manage our daily shopper resources.
Thank you, Derek. Yeah, so the next tool we're going to talk about is our daily shop resource and our access program. We developed this around 5 years ago, and this is when we get a fab release, we plug it into this system, and then we track between 5 different departments: plate processing, structural processing, fabrication, finish, and load. And the two main goals for this system is to effectively communicate how releases are getting scheduled to the shop so we can make informed decisions on the current workload, and it's easily to access. The second goal of it is to help support our lean principles, which I'll get into with our next start dates. So I'll kind of walk through. So our production office will get a fab release. We break that into what we call a lot, and they'll plug it into here, into this system, and they'll say, hey, what is required on this lot? Is there plate processing, structural processing, fab, you know, finish, and there's always going to be load. So from here on the left-hand side, you'll see each row is a different lot that we issue to the shop. On the right-hand side, the columns are the different departments. And if you look closer, each department has an overall scheduled date they're thinking they're going to complete that lot in the shop. And then there's the actual date it got complete. And then up top is the next start date, which we just kind of implemented over the past year or so, and that helps support our lean. In the past, you know, we would just put stuff in the shop based on delivery date. And like Derek mentioned, you know, sometimes you have a bunch of lots and releases that have the same delivery date or within a week, but they're all different. Like this one has high man hours, this has low man hours. And if you just strictly go off the delivery date, you're kind of pushing the work out, which means, you know, you could be over processing, so you're stacking material up, adding more material handling, or you have another department that's still waiting for material to get there to work. So the communication tool here is we have each department review these lots when they come out, and they put a next start date of when they would like to see material in their department to keep things flowing efficiently. And we kind of have it color coded here. Green is good, means everything's going as planned. It's hitting their next start date. Red, it's not bad. It's just a discussion point in our weekly meetings to say, hey, is this a problem, or are we going to be okay? So on this screen, you can click on any of the department, and it will go into a breakdown of all the workstations we have in that that department. So on the plate side, we track our burn table, we have a laser, brake, so on and so forth. Structural, we have angle line or Vortman line, and a few other workstations we like to track. So they will go in here and they will filter by each workstation, but they're filtering by next start date in. They're not going to look at the due date. That's our external customer, and we definitely want to hit that all the time. But now from a lean perspective, we want to meet our target dates of our internal customer. So plate and structural, their internal customers are either fab if there's fabrication, finish if it doesn't, it goes straight there, or if it's just cut parts, it goes straight to load, and it's the load target date. So example here, you see a red, we'll talk about the red saying, hey, is this an issue? What happened? Maybe it's not an issue. Maybe the vendor was late on one piece, so it's coming a couple days later, but they have enough work in the next department to get it going and still make the overall delivery date for an external customer. In this access system, we can also pull out just simplified reports we can hand out to operators. We're actually kind of going away from this and going more digital. But this is like the plate side. This is an example of our kinetic, basically sorted by whatever the next start date's going to be. That's their workload. Same for structural. This is a look at the fabrication schedule. We track different areas of fab in our building. We have a Fab 1, Fab 2, missed metals area. We even track galv repair, because all this data does flow back to other schedule things we have for like our PMs to see, so they don't have to ask any questions. It's right there for them to see. So on the front, the difference with the fab schedule, if you look on the front side, they can see the processes before them. They can see the plate dates and the structural dates. Then on the right end, they can see the next departments with their next start dates they're tracking towards and what their schedule dates are. On the fab side, when they have red, depending on the size of the lot, that may not be a problem or it could be a problem. An example, a couple weeks ago, our workload started to shift in our finish department. So it was more like 90%, for a few months. Well, now it's going 50-50. And now finish is kind of putting aggressive start dates for when they want material to come to them so they can stay busy. Well, sometimes on the mix of work, fab will put a date and it's red and like, hey, I'm going to miss this by 2 or 3 days. Is that going to be an issue? Or is there anything we can properly train, the finish employees to go help out elsewhere? Because that's part of lean too. You want to move the people to the work, not the work to the people just to keep them busy. You could level out your workloads by cross-training and send those people to the other departments to help. The example of the finish side, it's just like the fab, so they'll see the plate structural fab if it's required on the front end. And then their target is the load date. The great thing about this access schedule, we have a guy that can do some stuff to take that information from access and start feeding it to other parts of our systems. So we do a daily email subscription that he built, and it pulls that information from access, which basically breaks each workstation down that has a scheduled date and whatever the next start date is and where the next area it's going to go to. And then on the floor, we're starting to put that production whiteboard. I kind of mentioned those simplified reports we ran. This kind of is hoping to replace that here in the future for all workstations. So this will show about 72 hours forward of what's scheduled on that workstation or area. And then on the bottom half, it will show as they complete, and it will show areas for the material handlers where to take that material to. The next tool we have is our Strumis, our production management system. This is where you can go and look for your piece mark details, your assembly details, where it's routed, and where it's at in the process. This is real-time production tracking for the most part. For our cutting and operators, it's real-time. On the assembly side, it's more 3 times a day they try to update that. And this is a great resource for PMs, the production managers to help if their schedule dates are on track. It's good for detailers and everything when they got revisions to see where everything's at. The nice thing about Strumis is we can get as detailed as you want. It's kind of customizable. We basically track every workstation we have on the processing side, all our areas that kind of relate to our access system on the assembly side. And depending on how you have your filters, you can search the lot and it will show you where the piece is at in the process right now, if it needs to be cut or fab, or you can change your filter to say, I want to see what's actually complete. So it's really a good tool. Like I said, if detailers have revisions coming through and they need to make sure, is this part cut or is it FAD? What's it going to affect? They can easily go in here, and it's the same for the production managers to go in here and say, hey, how am I tracking towards our scheduled dates we have in our access system, which is communicating. And this Strumis data, every time they move it forward, we have some automation to it. So it does kind of communicate to our access system. So say the angle line's got a lot of work. Once the operator pushes all that stuff forward in that system, it will automatically plug an actual date. So the more automation means less time the production manager has to go into the system to actually plug an actual date in there, and it's more real time. So the more real time data you can get, the better your decisions are going to be for your current workload and how to react, when hot rushes pop up and all that good stuff. Strumis has a lot of good reports. This is just an example of an outstanding works report. Our loading department likes to load these as they check through, but there's a ton of reports in the Strumis side. Whatever you want, you can pretty much get if you want to track it. And this is just an example of our real-time tracking. So our operators are in this production console. This is where they move stuff forward. So if it's an operator for a machine, they're cutting stuff. This is where inventory management happens. Hey, I'm cutting this bar, but it's not the right E number. This is where they can exchange that bar and move it forward. And like I said, once they do that, we'll update our access system. Then also our assembly guys will come in here, our finish guys will come in here and they'll move their stuff forward, so everything's updated. And that's it for me on those resources. I'll bring Derek back up.
So we've kind of talked through, what does the flow of information, how do we, what different tools do we use to schedule our work in our shop? And this is kind of just another representation of how the information and the tools flow to one another. And I think it's critical to understand the nature of this, that the point is that we can't be in our silos. We can't have a production silo where all they care about is production. We can't have the PMs or detailing be in their own little silos and they don't understand the impacts of decisions to production. So we try to really create this open communication flow through these tools. And basically the flow is, we land a job, sales and PMs are assigned to it. It populates into our shop schedule. That gives us a good overview of how that project's going to affect our overall backlog. It's communicated out to everybody. Everybody knows that we have this new project. This is what our backlog looks like. From there, as the specific project information becomes more detailed, gets broken down to the sequence level, estimated hours get defined at the sequence level, we create those job-specific tabs. And once again, that's communicated openly to all of our employees. But that's when we start to feed into the access production schedule. Once stuff gets released, it starts to feed into our access production schedule. During that time, though, our engineering, our PMs, they understand where we have that work scheduled in our overall backlog schedule. And so we regularly manage and try to, understand what is the status of the drawings on a project. What is the status, like I said, of the project schedule. Detailing and PMs know when we need to have stuff in our shop for fabrication based off of all of our overall schedule and based off of their specific project requirements. And so they can look on our shop schedule and say, hey, design drawings are running behind, so we're going to be late on our approvals. What kind of impact is that to our overall production schedule? And we do that through our shop schedule. But that's just the constant communication that we have going on throughout the entire life of the project. Up front, we work with detailing to understand what kind of drawing schedule can they commit to that'll support our overall production schedule. And so those decisions are being made, that communication's happening on a regular basis throughout the project. Once it gets to our production schedule, stuff's been released to the shop. And once again, that communication is still happening, like Justin said. The PMs can use access to understand what the status of their project is, as more of a global. They can understand that, hey, we're fully processed on this sequence, because they can look in access, it's updated regularly, pretty much real time, and they can say, hey, in the past, we would go through and we would have 1 or 2 meetings a week, an hour to an hour and a half to talk through project schedules, go line item by line item. And it was good communication, but it just took time and it was unnecessary. So we started to utilize these tools And as long as we have the accountability and the trust that we're going to update the tools regularly, real time, now our PMs can just go into the tool. And yeah, they'll look there and say, hey, okay, I need to figure out if this sequence is done yet. They'll look in there and they'll say it. If they want more verified detail, they can reach out to us. But at least that's a tool right there that's going to say, yeah, it's done. And so we've eliminated those hour-and-a-half-long meetings, and now we meet, maybe 15 to 30 minutes once a week to go over project schedules just globally and say, are there any concerns? Do we have any scope changes that are coming? Do we need to evaluate something different? So that's our discussion now. It's more of a global view. It's not the finite detail, which we have all of our systems for the finite detail. So why do we need to waste time reviewing it every single day, But from Access production schedule, it goes into Strumis, and that's really, like you said, the shop schedule is an overall view. We're kind of drilling down as we go around the circle, The shop schedule is the overall view of our overall backlog. We drill it down to the production schedule. That's going to be at the machine level, our function level in the shop. And then you get into Strumis, that's the piece mark level. So like Justin said, if we have a bunch of design drawing changes and we have stuff released to production, our PMs and our detailers can go into the system, understand where it's at in production, and maybe that'll determine what direction we go on the revision. If it's already processed, maybe the revision is a different type of revision than if it wasn't processed already. And so that's the information we can get from Strumis at the piece mark level that's going to help us make the most educated decision when either changes come or project schedules need to be looked at. And it's just a continuous cycle, because once Strumis is updated and that stuff is done and complete out of our system, well, our shop schedule reflects that because we move on to the next week. And so it's just a continual process, but a continuing communication throughout our facility, throughout our company, of where our work is at, how we're trending, and all the information is there at the fingertips. And once again, this is done at our division level, so each division manages the process like this. So it's just a better, more efficient way. And communication is key in our industry. And if we can communicate the information, have it readily available to everybody, we're all going to be better off for it. And so this is kind of just a flow of that overall, of our philosophy, really, and the tools we use when it comes to production scheduling. And like we talked about, we really are transitioning and have been transitioning into, more of a lean philosophy and using lean principles to help guide our decisions, both on production, in the office, everything we do. There's a lot of benefit to lean, and I know a lot of people may feel like that, hey, well, I'm a job shop. Every single piece is different that I do. Lean should be applied to doing a million of one widget, and I'll say, yeah, you're correct, but the principles of lean apply to everything we do. 90% of the work that we do is going to get processed. 90% of it's going to have some kind of fabrication. 90% of it might paint. Well, those are, that's a pretty common flow there. So we need to evaluate our processes, but we can still apply lean principles to each of those functions. And so we kind of have, 5 main principles that we look at. And first off is defining value. What is value? What's value added functions? What are non-value added functions on our facility? And then like Justin said, we really look at internal and external customers. Of course, we do everything we can, and our number one goal is to support our delivery requirements for our customers. They're our external customers. But along the way, we have to fulfill all of our internal customer needs to help support that external customer. Detailing needs to provide a drawing schedule that's going to allow us to fabricate stuff in time. So we have to work through the whole process, but we have to view it that way, because it does no good for one department to sit in their silo and only be concerned about their schedule and not understanding the impact they have to the rest of our functions. And so that's why we really stress, hey, we definitely work towards we are geared towards supporting the delivery requirement, but as an internal customer, we want you to focus on supporting your next customer. Don't worry about the delivery date, because we're planning everything to support that along the way. And so that's kind of how we transition to that. We really map the value stream of all of our processes in our overall company, which really comes down to eliminating waste. Downtime's a good acronym for what the different types of wastes are: defects, overproducing, waiting, movement, motion, kind of aspects like that. And so we really look at processes and evaluate how can we eliminate waste in everything we do. Once again, at the end of the day, our customers are only paying for value-added functions. So we have to figure out how to maximize those value-added functions and eliminate all the waste that we deal with. And some of it's necessary waste. We have to move material throughout our facility, but can we minimize the number of times we move it and the amount of distance we move it? Those are things we have to evaluate on a regular basis. We create flow maps, map out the process, understand, okay, map out the process for this specific function. Who do you communicate? What kind of information do you need? How does the information flow within that process? And what can we do to improve it? And once again, you're looking at waste on that process. How can we benefit from that? How can we reduce waste? Like Justin said, we establish a pull system. That's probably been the biggest change for us. Historically speaking, we pushed the work out to the shop and said, work on it. We used to have the mindset that from a processing standpoint that we wanted to process as much as we could, so we had the biggest stacks of steel in the shop, so fabrication was buried. And all that does is create more material handling time, safety concerns, and everything else. And so we've got away from that. And it's been really hard because we used to measure how busy we are based off of the size of those stacks. And now you walk out there might be 10 pieces of steel on the floor. Well, that's because we have a pull system, and we don't need the other stuff yet. Our guys are working on the work they need to work on. The work they need next is right there, and the stuff they need after that will be coming down next. So we really have eliminated, and all that does too is that helps us utilize our square footage of our facility better, because now we don't have all these stacks of steel all over our facility. We can open up that space now for more value-added functions, and so that's kind of why we've transitioned to that. And it's been hard, but it's been a really good process. And start dates was the start of really a critical part of bringing that to our facilities. And then really, everything about lean is pursuing perfection, which we're never going to get there. So you really have to have the mindset of we're going to build it, we're going to build something, we're going to measure it, we're going to learn from that, and then we're going to redo it. We're going to build it, we're going to evaluate it, we're going to try to be as lean as possible. We're going to measure what we've done, see if what we thought was going to happen happened. If it has, great. If not, we're going to learn from that, understand why we didn't succeed to the level we wanted to, and then we're going to come back through and build it again and redo it. And that is the approach you have to have as a fabricator, as anything. We have to continually improve every day, and we're never where we need to be. And really, it's just a process that you have to go through, and it's tough. It challenges people, and change is always happening. But at the end of the day, we just need to continue to get better. And so we follow that build, learn, or build, measure, learn kind of concept throughout our facility. So that's kind of an overview of the tools we use to manage production, how critical we feel managing your production schedule is, and why it's critical, because it's really our production, what we do, that's the heartbeat of our company, and it's the most critical part. So we have to make sure that heartbeat is going as efficient, as productive as possible. So I have a couple assessment questions from the presentation. True or false, it is recommended to align the level of detail of both your estimating and production management systems. I think we kind of talked, yep, that's true. The caveat to that was that we're all going to have different levels of detail related to those systems, but do what you can to align them so that way you can evaluate your production side more efficiently and better. And then why is effective scheduling critical to a fabricator's success? A, to maximize utilization of your facilities. B, to fulfill commitments made to customers. C, we are in the business of selling man hours and material. Or D, all of the above. Yep, perfect. So all those things are more than good enough reasons to continually to improve your production scheduling, and which is going to result in you guys having more success. So I think that's all we got. So I don't know if there's any questions remotely or here. Yeah, go ahead.
What is your typical lot size in the structural, and then how do you estimate and track those hours? I think you were talking about tracking those hours by lots. Can you go into that a little bit?
So, when we have a project,
Mind repeating the question?
Yeah, sorry. The question was, what is the typical lot size that we track, like in our facility, and how do we define that? And so, projects are going to be defined to the sequence level, which is kind of an erectable, deliverable size for the erector. And then from there, we will take and define lots, and Justin can maybe go into more detail of some of the level of detail or how we decide lots.
Yeah, so the lots are based on the size of the sequence as well on the front end, but we're always learning. And like I said, we're kind of going into the lean side. So, back when lots were probably beams, columns, and, pour stops, miscellaneous. Well, now it's more, hey, on this sequence, let's do assembly, non-assembly, because assembly is going to flow through the shop different than the non-assembly. So it's easier to track and schedule. So yeah, the more we can make them smaller, the better off we're going to be tracking and be more efficient with our lean principles. So.
Yeah, and kind of, to your question though, we've had sequences where we might have 2,000 shop hours in one sequence, and that duration might end up being 8 weeks in our shop, and it's really hard to manage that much work at once because, the erector, the delivery date might be one solid date, but are you delivering what they need right away, or is it buried on all that still? So we try to shrink down the lots as best we can to allow it to track and flow better through the shop, but also it's a better end result for the erector because now they're getting the steel they really need instead of having to bury through, 1,000 pieces of steel. So, but it varies on every project. Some deliveries, like Justin said, we might sequence a sequence for columns, for beams, for roof beams, or we might have everything together, but then we'll break it down in our lot smaller to allow us to manage it easier on the production side.
Who estimates the hours?
Project managers. It's through the estimating. So we have an estimating department, and they'll, when we do that, they do that.
So when you break it into lots, it goes back to estimating to determine the hours for that particular lot.
So that's kind of the next step that we're taking because right now our estimating systems and our production systems aren't perfectly one-to-one aligned. And so as we're going through the evaluation of our new estimating software, we're going to align those down to the labor code level of detail. And so right now we kind of, we can break it out and we can go through and they can give us there's this much saw time, but I wouldn't say it's a really good, accurate, super detailed correlation to it. But so through experience in the shop, and then the access system actually has functionality to where when you bring in the information to the system, whether it's tonnage or piece count, it can assign a certain amount of hours to it too on the production side based off of it. Like right now it's based off of the historical data. So, on average it takes 1 hour to produce one quantity of angle or whatever it is. And we kind of use that historical data to populate our shop hours. But some of it's just to have an experience and guys understand what the work's really going to take. So, but the goal of the new system is to align everything and have it all automated through it. So I think there's.
Yeah, so when you start releasing things to the shop and you don't have material, is there any function here? I see you said the shop drawings, the project manager, make sure the shop drawings, I didn't see anything touching on, do I have the material for that sequence?
So we, a lot of times, we do a lot of big work, and so a lot of times we're ordering material early on off of advanced material lists and stuff. But that's all kind of tracked through Strumis, where we nest the material that we have to the specific piece marks, and that'll, we have reports that will say all this material for this lot's here, or some of the stuff's not here, and we'll dig into why it's not here. But we also, at the approval process, we typically will go through and review the material needs too to make sure that we have everything covered and nested too. And if we don't, then we'll bring it in. So the idea is that we have all of our material when it's released to the shop already, but we have through the different reports and through the processes, you can see which specific piece mark that material's not here yet, and we start to dig through it. Why?
Yeah, I would expect a check, like a lot. This is the date for the lot to be received. To start at the shop. Then there is a check saying is the material here 100%.
Yeah, Justin can kind of.
Yeah, I'll jump in. So the production office tracks that, so our cut list will have that information. There's stuff in Strumis that will say this, but I forgot to mention, but in that access system, we do have notes. So when they're in like the plate processing and they're at that workstation, there is a note, and we will like mark it saying, hey, all materials here. But most times, the production office controlling the initial release of cut lists, so they kind of know where material is at, so they're tracking that. And then that helps when those scheduled dates, are getting put in, all that stuff on the front end.
The idea too is that, we don't want our guys on the floor, our production managers having to worry about the material. We want, when it hits the shop, we want the material to be here. And so that's where the production office guys are using the tools they have to kind of manage that. And we try not to release stuff to the shop until everything's here, but depending on the size, or if there is a 1 or 2 piece hanging out, we'll release it and just wait for that stuff to come in. But yeah.
Does the project manager populate that detailed production plan that feeds into your kind of summary plan? And how does he manage the detailing approval part of it? Is that part of what he's looking at on that?
Yeah, so we have, yeah, sorry. The question was, does the project manager input the estimating information into our system? And then how do we manage the drawing status through that? And so through the Access, we showed you guys the production side of Access. We also have the project management side of Access, which ties directly to that. And we create a similar schedule where we have, they will take an upload and create the job in our Access schedule. They'll define the sequence level. They'll put the estimated hours in Access on their side. And that all translates into our shop schedule. But in that, part of that process is our project schedule. So when our drawings submitted, when do they return, when do they go to production, and then all the production dates feed back into that too. So they can look at their production, or they can look at their project schedule and see the completion dates for each of those different departments too. So it's all kind of combined together. But they're the ones inputting the initial estimated information into the sequence level. And then that just gets, then Justin brings that into our shop schedule from there. So.
It seems like that's the biggest variability.
Yep. Oh, yeah.
Process, that ability to get the drawings.
Yep. Yeah.
Yeah, just curious, you said about 3 times a day you do assembly updates.
Mm-hmm.
Is that done with a standing system or monitoring? And is that a supervisor or you above it?
The question was, we said we're updating our production tracking about 3 times a day on the assembly side, and who does that and what kind of tools. Today, they're just going into the system and updating it, and it's usually our production foreman that's been doing it. Maybe some of our leads out on the floor might do it too. The next step kind of, I feel like we're saying a lot of next steps, but is really looking at barcode tracking using, and Strumis has a barcode tracking functionality. We're waiting to kind of update the new version and use the iPads, and the idea is that we have iPads out there. We all have iPads right now. And so through the barcoding side, you can use production tracking real time using the iPad, and that's kind of what we're waiting to move into. So, but yeah, I mean, the production leads or production foremen are updating the system, for the assembly side. And like Justin said, on the specific sub-material piece mark, the material side, that's getting updated real time as it gets relieved from inventory or processed. So, yeah.
Following up on that question, how many employees total would you say are involved in managing your data system?
Well, inputting data, I mean, we have all of our guys on the floor will use Production Console and Stru to update Strumis. Justin really manages our shop schedule, the main first backlog summary. He's the one doing that. And then the Access schedule, our production foremen are in there putting in their schedule dates. But that's really it. So that's, 5 people there maybe.
Project managers build the data when the job's created?
Yeah, yep. They build their project schedule in the project management side of Access.
How many project managers do you guys have?
We have in Omaha, we have 6, and in Denver, we got 4, I think. So, and that's, I think some of the struggle with the systems initially is, God, that's going to take so much time to update it. What do we, our guys don't have time. I can't have my guy pulled away from the floor to input a system. Well, at the end of the day, it doesn't take that much time because of how we built the system, but also it's critical that they have their thumb on everything they're doing. They understand where production's at. That's where they're going to bring the most value. And so if they have to spend 10, 15 minutes 3 times a day to update the system, it's well worth it. It is, because they're going to have a great understanding of where it's at, and everyone else in line is going to understand where that work's at too, because now our system's updated and it's all there for them to see. So, yeah.
A few more questions. So do you measure efficiency for each job, or do you measure it by lot you do, and do you compare best and contractual for that specific lot?
We measure efficiency at the sequence level. Since our initial sequence hours are at our estimated hours at the sequence level, But through different other reports, through Access, we can look at each sequence, the amount of hours charged per labor code, and how that translates to the estimated hours. And then we use that as an initial gauge, we're right at, we're under. And then if we see trends, or if we see, hey, we're way under, why? Then we can go back to the PMs and say, hey, give me the breakdown estimate for that sequence by labor code, kind of by function. We have this many welding hours, this many fitting hours, and then we can really see, okay, this is where we're over or where we're under, and that's why. So.
The project manager will be able to do the estimate for the actual shop drawings, or he pull estimates from the original estimate?
Original estimate, yeah. When we go, like if we need to go through and evaluate production or productivity, then we will at times use the shop drawings, because maybe there's a disconnect between the initial estimate and what the actual shop drawings are getting released. So that might be part of the process of evaluating, hey, why are we over or why are we under? We'll look at the shop drawing, see if this is really how we estimated it. A lot of times you might get weld details might kill you, because they didn't estimate a certain type of weld or whatever. So those are the level of details you have to go through if you're going to evaluate productivity. But we don't do that every project. It's really as we identify issues or trends, we'll dig through that level of detail to understand where it's at. So.
For us, we were using barcoding in our campuses.
Yep.
We also developed the software that can do, you get a model, capsule, instead of instruments, and
Yep.
we can develop hours piece by piece, part by part.
Okay.
When we give it to the shop. So when we release a shop, release a lot, I know exactly how many hours for each piece.
Yep.
How many hours for slow rail with that well painful.
And the painful thing that, with we're going through with the estimating evaluation and changing estimating systems, the good result of that is going to be that we are going through and reevaluating and doing time studies on all of our functions. So that way we have the good accurate data to upload that into Access. Because like I said, Access will take and define, and Strumus has the capability to define, hour per piece or hour per lot. And so as we go through this process of switching estimating systems, and we go through the process of doing all these time studies, we'll have a better feel for, where our production stands today versus the estimating system that was built 20 years ago, so.
We have one question online.
Yeah.
Do you schedule all of your work from one centralized location and delegate to other divisions, or does each division generate their own work and documentation?
Yeah, the question was, do we schedule our work for each division in one central location, or does each division kind of schedule their own? And so each division will manage their shop schedule document, but then we meet every week or every other week for 15, 20 minutes to talk about that and understand where the backlogs are at. So we'll meet with our Colorado facility and talk through the shop schedules, but those shop schedules are communicated, like I said, every week to everybody, so everyone kind of has a good feel. But we have a production coordination meeting between divisions, usually every other week, just to kind of evaluate our backlog schedules and understand. And that's where the discussions start to happen of, hey, we see you're a little light, in a few weeks. Maybe we should transition some work to you guys. And that's kind of how that happens. But they're managed by each division. So. All right. Well, I appreciate everyone's time. Safe travels back.